We're going to be using a gun and a ballistic pendulum to find the speed of a projectile in meters per second and feet per second.
A ballistic pendulum is a pendulum used to measure how fast a projectile is going. Ballistic pendulum has been used for ages and even from the start of guns.
Right now we're measuring the weight of the clay as well as the stick that'll hold the clay on the bottom of our pendulum so we can figure out how many meters per second the projectile of our gun will shoot.
Okay, so now we're going to calculate the weight of the clay and the stick, and that is 1,443 grams. Right, so now we will then add that into the equation to find the meters per second. I'm going to put a stick in the arm of the pendulum, then push the pendulum down into the clay with the stick. Okay, so this is our pneumatic air gun that we made for the project. It is composed of a PVC tube that holds the air, a ball valve, and a copper barrel, and this gun will be powering the projectile that will be coming out of it.
We're going to use this compressor to pump 100 psi of compressed air into this chamber.
And then use the valve to release the air and shoot our battery as our projectile.
Okay, so now we're going to measure how many grams this AA battery is. As you can see, it's 25 grams.
Alright, so the reason why we had to switch from the pneumatic gun to the airsoft gun was two reasons. The first reason was the medium that we used for clay on the bottom of our pendulum was causing two issues. The first issue was if we used a smaller amount of clay so that we could get a better reading on the arm, the bullet or our battery from the gun would just blow right through it and it wouldn't be embedded inside of the block of clay, which we needed to happen. The second problem was when we bumped up the amount of clay to make it bigger so that the battery would get embedded, and if we lowered the PSI, the arm of our pendulum would not swing enough so that we could calculate a good enough information to plug it into our formula to find meters per second. Alright guys, we hit some complications with our homemade pneumatic gun. So we have a backup plan, and it's to use this spring-loaded airsoft gun. It shoots these little pellets, and we're going to use this now to find how many feet per second this gun shoots these little pellets.
Okay, so now we're going to measure the mass of the styrofoam, which will soon be shot, and will be the bottom of our pendulum. So we're going to come over here and put it on the scale, measure it in grams, and as you can see here, it's 14 grams. Okay, so now we'll put it on the pendulum, and it will be shot.
Alright, so we set up our new pendulum right here, and we set up the board so that this marks the trajectory of the arc that the pendulum's going to go, and each one of these lines is 1 centimeter. So what we're going to do is we're going to shoot this and see which one of these it goes to and measure how far it went.
Alright, so during our project we learned two laws, the law of conservation of mechanical energy and the law of conservation of momentum. The formula for law of conservation of mechanical energy is kinetic energy initial, which is the BB, potential energy initial, which is the styrofoam, kinetic energy prime, which is the BB, plus potential energy final for the styrofoam. And then how you plug this in is you use the mass and the velocity, mv squared over 2 equals potential energy final, which is measured in joules. And for the law of conservation of momentum, you use mv for the styrofoam plus mv, the mass of the BB, and equals mv, which is BB times styrofoam.
Okay, so now what we're going to do is we're going to calculate the meters per second and the feet per second of the projectile. We're going to start off by getting our measurements. The styrofoam is 0.014 kilograms. The pellet, which is the bullet, is 0.0002 kilograms, and the height that the pendulum travels in meters is 0.045 meters. Now what we're going to do is we're first going to start off with our equation for the law of conservation of mechanical energy. Adding all of our stuff in, we ended up getting our gravitational potential energy, which is 0.0062 joules. Right now, for our mv squared over 2 up here, we end up getting 0.934 for that. So then dropping down to here, this would be our law of conservation of momentum. This is our equation here. Plugging everything in, we drop down here after dividing everything by 0.002, which is the weight of the BB, or pellet. We end up getting 66.3 meters per second. Now if we want to calculate that into feet per second, we drop down to this proportion, and then we calculate that to get 212.16 feet per second. And that's how fast our bullet is traveling.